Welcome back to Sunki Maths class. Today we shall continue our class on MAT111, but the topic for today is mapping. What is mapping? Mapping is an association or a relation between two sets. Mapping is an association or a relation between two sets. There are basically 6 types of mapping, but I'm going to be explaining just 5 for today. So let's start. The first one is one-to-one mapping. And this is also referred to as the injective mapping. Now, a mapping is said to be one-to-one or injective when the elements in the domain are uniquely paired to a single element in the codomain. Let's take, for instance, we have two sets S and T. Set S is A, B, C, D. That's the element. W, X, Y, and Z. A is mapped into, sorry, this is a function of mapping. Like S is being mapped to what? To T. A is mapped to W, B is mapped to X, C is mapped to Y, and D is mapped to Z. Now you can see that this line is our domain. This is our domain, and this is the codomain. So a mapping in which the elements in the domain they are paired to a single element in the codomain is said to be one-to-one mapping. So you can see they are single element, they are paired to a single element. Now the second one is onto mapping. We call that surjective. That is also called surjective. SUR. Now it's also called surjective mapping. Now a mapping is said to be onto or surjective if every element in the codomain has at least one image in the domain. Another instance here, you are still considering set S and T. S is being mapped to T. We have element of S and we have element of what? T. So let's take this as A, B, C, W, X, Y. A is mapped into W. C can be mapped into X and B can be mapped into Y. So you can see that the codomain side here is having at least one image here. It's having at least one image. They say at least means it can be more than one image. Let's take an instance. Let's take A, B, C, and D. And we have W, X, Y, S, T as a function. So you can see this is mapped into this. This is mapped into this. This is mapped into this. Now, but we said at least the codomain can have more than one image. So that means if I should take this with this. So you can see that based on what we have here, X is having more than one image here. Are you following? X is having more than one image here. So it's having both B and D. So this can also be onto what? Mapping. Are we together? So this and this, they are the same. Now, onto mapping can be one-to-one mapping because if you look at this one, this domain are mapped into a single element. So it can be onto mapping can also be one-to-one mapping, but one-to-one mapping can never be onto mapping. And that is what gives rise to the third type of word mapping, which is known as surjective mapping. Sorry, which is known as the bijective. Bijective, that is combination of onto and one-to-one. So onto and one-to-one mapping. So this is known as bijective. So you can see this, I can bring this example back here because this is onto, it is also one-to-one. So example is S, A, B, C, T is being mapped to T, W, X, Y. So this is mapped here, this is mapped here, and this is mapped here. So this type of mapping is said to be bijective because it is both onto and is also what? One-to-one mapping, but not this one. Are we together? Okay. So the fourth one, we have identity mapping. Now a mapping is said to be identity when the element in the domain is the same as element in the codomain. Let me take that again. A mapping is said to be identity when the element in the domain is the same as the element in the codomain. So now, for example, set S and set T. is being mapped into T, A, B, C, C, A, B. Look at A is mapped into his image, C is mapped into his image, B is mapped into his image. So this type of set is known as the identity set. That is when the element in the domain is same as the element in the codomain. So this is type of identity set, identity mapping rather. So we move to the last one, which is okay, can I manage? Okay, let me manage this please for that. Number 5. We call that constant mapping. Now, constant mapping, a mapping is said to be constant if the element, all the elements in the domain are mapped to a single element in the what? Codomain. An element is said to be constant when the element, all the elements in the domain, they are mapped into a single element in the what? In the codomain. That is set S T A B C W X Y. So this is mapped into X, this is mapped into X, and this is also mapped into X. So you can see all the elements in the domain, they are mapped into a single element in the codomain. So they are said to be constant mapping. Okay guys, this is what I have for you today. Please, if you enjoyed this video, kindly give this video a like, and don't forget to subscribe to this channel if it's your first time viewing my channel, and turn on the bell notification to stay tuned on my YouTube channel whenever I release a video. Bye for now.